Bismillahirrahmanirrahim. In this lecture we will study some properties of permutation symbol epsilon I j k, and then manipulation within the indicial notation. Now first property of this permutation symbol is written here. So we can see that epsilon ijk is equal to 6, that if we have the product of this permutation symbol with same indices, that ijk and ijk, then its result will be 6. So it is very simple to show this. Let us take left hand side, and this is left hand side, and we have seen that we can see that we have 3 dummy indices I, j and k. So first we will expand I, then j, then k. So it depends on you that first which symbol you will expand. You can start with any symbol by expanding any symbol, by expanding any index ijk, not symbol, index. So this is expansion of the index I from 1 to 1 plus 2 plus 3. So we have 3 terms. Now we will expand the indices j and k. You can see that j and k, they both are dummy indices. From the first term, first you can expand j or k, like second, and like, and this as like first, you can expand it in the third term, j and k. So here I have written that we will write only non-zero values, that these terms, the values of these terms are non-zero. We have more terms, but they are 0, so that is why we did not write those terms whose values are 0. So we have written only those terms whose values are non-zero. So because you know that when you have repeated indices for permutation symbol, then its value is 0. So we have written only those terms which have no repetition. So 1 2 3 1 2 3 2 3 2 3 3 2 3 2, plus here we have 2, so 1 3 3 1 1 3 3 1. So here we have 3, so we can write 2 3 1 2 2 1. So these are the 6 terms. These are the 6 terms coming from these 3 terms, which are non-zero 6 terms. So plus 1 minus 1 minus 1 minus 1 minus 1 plus 1, then again plus 1 and minus 1. So at the end we have 6, which is our right hand side. Now the second property, you can see that what is the second property. We have epsilon pjk qjk equals to 2 times delta pq, that here we have again product of permutation symbol in second property, but there is a little difference between first and second property. In first property you can see that all the indices are same, ij, ijk and ijk, but here in the second you can see that one index is different. That first permutation symbol has first index p but second permutation symbol has first index q. J and k are same, but p and q, they are different, they can be different with each other. So it would be equal to 2 delta pq. This is the symbol delta pq, Kronecker delta. So we have two cases here. First case when p and q are same, and the second is when p is not equal to q. For first case when p is equal to q, then we have right hand side 2 delta pp, so it would be 6. But for left hand side we can write pp, it would be epsilon pjk and pjk. So for using first property, as all the indices are same, so it would be 6. So for second case, p is not equal to q, so right hand side is 2 delta pq. Since we are saying that in this case that p is not equal to q, so 2 into delta, this delta p, this is delta pq is 0 because p is not equal to q. And for left hand side we can take any pair of p and q with p not equal to q. So let's take 1 and 2. So when we have used 1 and 2, then it will be epsilon 1 jk, 2 jk. So we have summation on jk. After expanding the summation on jk, this is a non-zero term when we have expanded j. So epsilon 1 3k, epsilon 2 3k. Now again we will expand this, and this is 0. All these terms are 0, so left hand side is 0. So you can check for any pair of p and q, it would be 0. Here you can also check with any pair that if you have 1 1, simply you can take p is equal to q is equal to 1. So here it will be 2 into delta 1 1, that will be 2. And for left hand side here will be 1 1, and you can open summation on j, again you will have 2. So this is an exercise for you people, that if you have product of epsilon ijm there, you can see that we have only one index repeated, m is repeating, and ijkl, these are free indices. So right hand side will be this. So by using this property of the product of permutation symbols, you have to derive above two properties with the help of this relation. So this is an exercise for you. Now these are something which we will use in our further lectures. These are notations. This is simple, the notation for partial derivative of u, that if you have ui, then partial derivative with respect to xj can be written partial ui partial xj. These are the same as partial u1 partial x1 partial u1 partial x2 partial u1 partial x3. So in general, within indicial notation, so you can write this partial derivative as partial ui partial xj, or you can write this as partial j ui. Now this is for divergence. So divergence of u, as you have written a cross b in the indicial notation, where we have made use of permutation symbol while writing A cross B in indicial notation. So this is the indicial notation, the indicial form of this divergence of u. As you know that del dot u is equal to partial u1 partial x1 plus partial u2 partial x3 plus partial u3 partial x3, and this is the sum. So this sum can be written as partial ui partial xj, or in this way partial I partial ui. That this is simply, you can write it as partial 1 u1 plus partial 2 u2 plus partial 3 u3. No, this is for curl of u. This is the same as A cross B. Now this is any ith component of curl of u. This is equal to epsilon ijk partial j uk. Now this is the derivative of this uk, partial derivative of that. This is partial uk partial xj. Now this is any ith component of curl of u, any ith component. So this is with the help of this indicial notation, now we are going to write the first component of curl of u. So this would be this is how we can write the first component, the 1. Then we will expand j and k. It would be this. Then we can write this is plus 1, this is partial u3 partial x2, this is minus 1, this is partial u2 partial x3. Similarly, you can have second and third component of this curl of u. Now some manipulation with indicial notation. These manipulation includes substitution, some multiplication, contraction, some factorization. Well, first substitution, that how we can substitute any equation in another equation in the form of indicial notation. That if we have two equations and they are in the form of indicial notation, then how can we use one equation into another equation? Simply as you do this thing in your algebraic equations. While dealing algebraic equations, simply you usually use value of one variable into another variable. Here we will have to use one equation into another equation while we have these equations in indicial notation. Suppose we have this first equation, which is ai equals to uim bm, that we have a quantity a whose ith component is the product of imth component of u and mth component of b. And this is the second equation, that ith component of b is in this form, product of v and c. So now we have to use this second equation into first equation, that we want to put this second equation into first equation. So if you will try to put second equation into first equation, then first you need to make second equation of b similarly in the first equation as b is given in the first equation. That in first equation, index subscript of b is m, but in second equation we have I, so we have to change this I by m. So we will change this I by m. So it means that in second equation I is free index, so when we change this I by m, so we have to also change this I on the right hand side of the second equation. So here it would be m. if here it is m, then we have already 2m in second equation, so we cannot write these m again. So we will change this m with any other index. So we can write this m by n. So we have bm is equal to vm and cn. Meaning of 2 and 3 are same. That if you calculate b1 from 2 and b1 from 3, they will be exactly the same. They cannot be different from each other. Now we are in the position that we can use this bm in equation number 1. By using this bm in 1, we have simply ai equals to uim and vm and cn. So this is some restrictions which we have to follow while using one equation into another equation with indicial notation. Now multiplication. If you have p as in 1 and q as in 2, then you can multiply these two simply. P is am, bm and cm, dm. So you cannot write like this because this is not defined in the, this thing is not defined in the summation convention. So you will change c and dn, that you have m is dummy and n is also dummy. Also if you have like this, then yours, and you will open this, then it can't be equal to this thing. That simply you have to keep in mind that m should be remain dummy and n should be remain dummy, and for dummy they should appear 2 times and they should repeat 1 time. So they can't be occur more than 1 time, more than 2 times, more than 2 times. Now here we have written a dot b, as we have written a cross b previously. Here we have written a dot b. This is very simple. This is a is equal to ai ei and b is equal to b I ei. So a dot b is equal to, this is a dot b. You can take ai bj outside because they are simply the scalar components, simply the scalar numbers, and a1 b1 a2 b2 like this. And you have ei dot ej. We have changed this I by j because you cannot write like this ai ei dot bi ei. Now this ei dot ej, you know that this is delta ij, so you have this delta ij. Now it would be, this is ai as it is, and this j are dummy, so it would be bi. This is the property of Kronecker deltas, which we have studied in our, I think, second lecture, where I was telling that we will make use of these properties in our course. So it is either can be aj bj, it would be a1 b1 plus a2 b2 plus a3 b3. So a dot b equals to simply ai bi. Now factorization. That we have 2 terms in equation number 1 and we want to write this equation number 1 in factors form. Now we have tij and j minus lambda and ni, so we can see that I is dummy, I is free here. So we will use the property of Kronecker delta. This ni could be written in this way, delta ij and j, that if you will contract this j, you will have an I. So you know you can use this equation number 2 in equation number 1 and we have this form. Then you can write 3 in the form of 4. So this is the factorization of this equation number 1, that we have made 2 factors of this one. Now contraction. Now contraction is basically a simple operation of identifying 2 indices, 2 free indices, and then making sum on them. It is known as contraction. So this is the simple example of the contraction, that as we have Tij, so we can see the 2 indices I and j. So you can identify these 2 indices as I and j. Now you will have to make sum on these, on this index. How can you make the sum on these indices? For this you have to make these 2 indices same. Either it can be Ij or Jj. If you have Ij, then Ii, then it will be T11 plus T2 plus T33, or it can be Tjj. That would also be T11 plus T22 plus T33. Now if your Tij is like this, lambda theta delta ij plus 2 mu eij, then your contraction will be Tii. And now I and j are the free indices in equation number 2, and now you can make sum on these indices. How can you sum on this? By making these the same, that Ii, that you are contracting these free indices. Now let's see what happens while contraction. Then here you have 2 free indices, and here you have no free index. That you have done 1 contraction and you have no free index. Now similarly, if you have 3 free indices, then how many contractions you can make? First contraction is this, then you can make Ij similar, then you have this equation. You can see that here we have 3 free indices, and here we have 1 free index. You cannot make any further contraction on this equation, that you cannot write Ki. K is equal to y. Another contraction can be this, that you can make j and k similar. Another can be this, that you can make I and k similar. Now if you have 4 indices, then how many contractions can you make? You can do this as Tiikl, Tiji, Tijki, that you can make I similar with j, then with k, and also then with l. Then you can have contraction by making j and k same, j and l same, then with k and l same, and also you can write Tiikk, another contraction. If here you have 4 free indices, first contraction will give you 2 free index from 4, and if you will again contract this, then you will have no free index, 0 free index. So this is simple the example, that how can we contract this, that how can we use contraction. Thank you so much.